All right, let's go through 5B weather relationships review, see how you did. Don't beat yourself up too much if you miss a few. These are certainly, some of them at least are pretty tough because relationships, one thing can affect another and it's easy to get lost in it. But we will soldier on. So during what part of the day is relative humidity usually the lowest? So low relative humidity means the air is nowhere near its capacity for water. It's not close to being full even. And that happens, the warmer the air is, the more water it can hold. So the warmest part of the day is usually when humidity is the lowest. So warmest part of the day you should remember is mid-afternoon. Air molecules have the greatest average kinetic energy at which of these temperatures? So you have to look it up on the reference tables on page 13 where the thermometers are located and figure out which one of these is the hottest. There's no easy way around it unless you really understand these systems. So you look at page 13, you find which one is the highest of the temperatures, and that means it has the most kinetic energy. And it just so happens that it appears to be 0 degrees Celsius. Alrighty, number 3. Methods of rainmaking are usually directed toward attempts too. So if you want it to rain, we've established that to form raindrops, there's a few options. You have to have water, you have to have something for water to stick to. Those are the big ones. The air has to be saturated. So if you increase the temperature of the air, that's going to make it less full. Warmer air can hold more moisture. That's probably not going to leak. Increase the moisture in clouds. Well, I hate to break it to you, but if you need rain, I'm not sure where you're going to get the water to dump into the cloud to fall out. That just seems like a silly idea. You probably should just use that water on your crops if you need it. Raise the height of the cloud base. Not sure why higher clouds would be a good thing. Number 4, I like number 4. Provide condensation nuclei. If you sprinkle little bitty material into a cloud that's already pretty wet, maybe, just maybe, that will encourage enough condensation to happen where the droplets will get bigger and rain will fall out. That's what they try for. They use this stuff called silver nitrate at last I knew, unless they've come up with something better. If each of the following covered 1 square kilometer of Earth's surface, which would transfer the most moisture to the atmosphere on a warm summer day? Well, warm summer day, I'm going to go with the forest because plants expend energy to push out water. So they're going to be really rocking. Though honestly, lakes are going to evaporate a lot too. So it sort of depends on the forest, it depends on the temperature of the lake, it depends on. So if you put 1 or 3, you're on the right track. I don't think they would do that to you. I know I wouldn't do that to you on a test. Number 5, as the rate of molecular activity of a liquid increases, the rate of evaporation of that liquid. So rate of molecular activity increases, the rate of evaporation will. So molecular activity is a fancy way of saying the molecules are moving faster. So if the molecules move faster, that indicates you have a higher temperature. If you have a higher temperature, that's going to increase the rate of evaporation. Number 6. As the exposed area of a moist object decreases, the rate of evaporation will. This is a good one for an example. If you take a moist object, a wet towel, you got out of the pool, you dried off, it's all damp. Now, if you take that towel and hang it up, it's going to dry pretty quick because you spread it out, you increased the surface area. Now, if you wad that thing up in a ball and shove it in the corner somewhere, you decrease the exposed surface of it. That's going to slow down how fast evaporation can happen. That's going to decrease the rate of evaporation because not as many surfaces are going to be exposed to the drier air. Number 7, as the amount of light striking a moist object increases, the rate of evaporation of liquid from that object will increase. Again, light brings energy, energy raises temperature, more evaporation. Number 8, as the amount of water vapor in a given volume of air increases, so more water in the air, the rate of evaporation from a moist object will decrease. Because if the air already has water in it, That means there's less room for more to get there. So as a result, it takes longer for it to find an empty spot. Number 9. As the temperature of a given volume of saturated air decreases, the condensation will. Oh, this is a tough one. All right, so let's say it's 70 outside and the air is saturated. Now, if I take that air that's already full and then I make it cool down, it can hold even less moisture. So it's going to increase the rate of condensation because, again, I like analogies. Imagine a sponge. If you had a sponge and it was full of water, you poured water on it until just no more would stick. Now, if you let that sponge just sit there, it's going to stay there nice and full and wet and not really leak to speak of. But if you take that sponge and then you squeeze it, the water comes rushing out because you reduced its ability to hold it because you're now forcing it to come out. That's kind of like this air. It's already saturated and then you cool it down more. It really can't hold that water. It doesn't have the energy for it. It's going to come out. That's one of the reasons we have the lake effect snows and rains around here. Winds come off the lake, they're forced up the Tug Hill Plateau, which cools them down. They already had a lot of water, and now they're going to get more condensation. Number 10. If the relative humidity on a given day is 70%, well, relative humidity is the percentage of fullness. Not that that's the greatest English, but we'll roll with it. So it's not composed of 70% water. It holds 70% of its water capacity. I know that's it. There we go. That's going to work. Holds 70% of its capacity. It's 70% full. During a given year in Albany, New York, the relative humidity for a certain day in February is exactly the same as a certain day in June. What's the probable explanation? So this could happen. You could have a day in February where it's 75% humidity. You could have a day in June where it's 75% humidity. And remember what that means. Relative humidity is the percentage of fullness. So they're both 75% full. All that means is, yes, the temperatures are different, but the dew points are different too. So different amounts of water in the air, but the percentage of fullness stays the same. The dew point in the wintertime might be 15 degrees. The dew point in June might be 55 degrees. But you could still work it out to have the same percentage of fullness. 12. As air temperature rises, the relative humidity will decrease because warmer air has the ability to hold more moisture. So if you have a certain amount of water and then you warm the air up, now it could hold even more water, so percentage-wise it's less full. As a mass of air increases in altitude, its pressure will. The higher you go, there's less air above you, so that means there's less pressure on you, so the pressure will decrease. As the pressure gradient increases, wind is caused by differences in air pressure. So if you have a small difference in air pressure, you have a small wind. If you have a big difference in air pressure, you have a big wind. So if the pressure gradient, so the difference between one place and another, increases, the wind velocity will increase. 5b, so we have a graph. So hourly surface temperature, dew point, and relative humidity. Month of May in Washington, D.C. So temperature is a black line, dew point's a little bitty fine line, which doesn't change that much over the course of a day. The water in the air stays pretty constant, more or less. And relative humidity, percentage of fullness. So what do we have? The greatest net change in air temperature occurred in which period? So no easy way, you just have to look at all the segments. Looking at it, it looks pretty steep right here. So if there's a segment that goes from 6 a.m. till noon, is there one? 6 a.m. Yeah, 6 a.m. till noon, that's going to be your biggest chunk where it changed the most. So that's what I would do. I'll pick that one. Come on, pick it. Got it. The graph indicates that as air temperature increases, humidity does what? So, all right, low air temperature goes up, Humidity is this one. Humidity, whoa, nosedive, goes down, decreases. Condensation is most likely. Condensation happens when there's nuclei available and the air is saturated, or at least close to the dew point. So, temperature is black line, dew point's little bitty dots. They are just about touching right there. And the humidity is really crazy high too. So, all that combines to tell me that 6 a.m., it's probably raining or foggy, something where there's a lot of condensation in the air. Which conclusion concerning the relationship between the dew point and air temperature is best justified by the data shown? So we got our data. Now we just have to, these aren't my favorite questions as a student taking this, because you have to read through them all. There's no easy, obvious answer. Changes in dew point do not necessarily occur when air temperature changes. Well, let's see. Air temperature, dew point. Air temperature went up a lot there. Dew point didn't. Kind of liking that answer already. Let's see what the others say. The dew point temperature increases in proportion to an increase in air temperature. Well, that's not true. That would mean they like go up similar amounts or something, and that one goes way up and this one stays flat. No, that doesn't work. Dew point increases in proportion to a decrease in air temperature. Again, nope. Changes in dew point are caused by changes in air temperature, but not in proportion to these temperature. That I'll buy. Okay, that one I can buy. Because, I mean, from sunrise till throughout the day here, when the temperature goes up, the dew point did rise. It took a while, but it rose. And then when the temperature goes down, it does go down. It takes a while. So they do respond to each other, but not equally. It's a real small change. So I like that one. That's a tough one. At a temperature of 60 Fahrenheit and a relative humidity of 51%, we warm that up to a temperature of 70 and a relative humidity stayed at 51%. So the air warmed up 10 degrees, the percent fullness stayed the same. That means the moisture content increased. In order to stay the same percentage full, when you have a bigger container, a warmer chunk of air here, you're going to have to add water to it. 20, a barometer indicates a pressure of 30 inches of mercury at sea level and 3.5 miles above sea level. It indicates a pressure of 15 inches of mercury. What's the best conclusion to be drawn? So by going from sea level up 3.5 miles, there's now half as much pressure. So humidity affects pressure. It doesn't mention humidity at all. Temperature affects pressure. It doesn't mention temperature at all. Of the total mass of air, 99% is within 3.5 miles. So that would mean if I go up 3.5 miles, it should go down 1%. It went down 50%. So 50%, there we go. An air pressure of 30.15 inches of mercury is equal to what? Well, let's see. 29.92 equals 1013.2. So that's our standard basic air pressure. So if I have 30.15 inches of mercury, I'm going to have to look that up. I don't know off the top of my head. So you grab a reference table and you look it up and you get an answer. It's on page 13. See if I can find it quick. I don't know if I can. We'll just do it the easy way. Google, where are you? Play nice. Or even better. I know how you guys roll. 30.15 inches of mercury. .15 inches. 20.999. Okay, so 21. Sorry about the delay there. Can't do everything off the top of my head. So 21. It's on page 13 in the reference tables as well. Which process is likely to remove pollutants from the air? Precipitation, because it washes out all the condensation nuclei, which are often particulates of pollution. Temperature of 104 Fahrenheit is equal to a temperature of 40 degrees Celsius on page 13 again. 37 is your body temperature, so that's right around 100. So just a few degrees warmer than that. That's how I knew that one off the top of my head. It's a little easier than the inches of mercury. Which is not true of the wind. Wind is named for the direction it comes from. So not true. Wind is named for the direction toward which the wind blows. There's your falsehood. Turn it. Come on, buddy. Okay, works. Which is required to cause evaporation and transpiration? You have to add energy in order to make those happen. If you want water to evaporate, you have to add energy. If a plant wants to pull water up from the roots, it has to expend energy. Air moves from regions of high pressure to low pressure. Winds always blow high to low. There's not always a compass direction. It's always from high pressure to low pressure. If you're outside and the wind is blowing in your face, well, that means you're looking toward high pressure and behind you is low pressure. The process by which water vapor changes directly to ice. Sublimation. Which temperature will water vapor change directly to ice? It would have to be below freezing for that to happen. The only one of our choices that's below freezing is -10 Celsius. Water vapor forms clouds by means of condensation and sublimation, because in order to form a cloud, it has to turn into a liquid droplet again or a snow ice crystal. Precipitation occurs, let's see, when air cannot support the droplets or ice crystals, whenever the dew point is reached, when air is rising in large quantities, whenever the clouds are thick and dark. Okay, so anytime there's clouds, there's droplets. But you don't always get precipitation because they're tiny little droplets and the wind is going up quick enough. However, if the droplets get big enough or the ice crystals get big enough and the rising air is not fast enough, it'll fall out and you'll get precipitation. Moisture enters the atmosphere from plants. Plants are transpiration. Which of the following would most easily result in condensation? So the air becoming full of moisture and droplets forming again. Let's see. You don't want dry air. You don't want dry air. Moist air, pure moist air. Moist air with dust. That way you have condensation nuclei. That's better. The most energy is required to cause. Ooh, I should have removed that question probably. Well, condensation releases energy. Sublimation releases energy. Evaporation and transpiration need energy. I don't think I mentioned that word, so if you didn't get that one, I forgive you. And number 11. If the temperature increases and the dew point remains the same, temperature increases and dew point remains the same, that means they're going to get further apart. That's going to decrease your chance of precipitation. Decrease your chance of precipitation. All right, that was a bit drawn out, but it was a long assignment, so hopefully that helped. Thank you for watching.